Hello students, welcome to the class. In the today's class, we are going to discuss the principle, construction and working of the Helmholtz galvanometer. So before going to the start of the Helmholtz galvanometer, I just want to say something introduction about the galvanometer. So already you studied the galvanometer. The galvanometer is an instrument which is used to measure the current. So already we know this one. So galvanometer is used to measure the current, but a sensitive current it will measure. So that is what the difference between the galvanometer and the ammeter, because both the instruments are measuring the current. So as we go to the galvanometer, here I am taking the two types of the galvanometer. One is the tangent galvanometer and another one is the Helmholtz galvanometer. The tangent galvanometer also used to measure the current only, as well as the Helmholtz galvanometer also measure the current only. But there is a certain differences is there between tangent galvanometer and Helmholtz galvanometer. So to study that, I want to show you the instrument of the tangent galvanometer and the Helmholtz galvanometer. So this is nothing but the tangent galvanometer, from which we can determine the current. The thing is, it works on the principle of the tangent law, which one we studied in the last class. So if you see my last video, you will come to know what is the tangent law. So according to the tangent law, B is equal to BH into tan theta, or whenever the current is passing through any conductor, it is producing the magnetic field, as we know. But we are taking two magnetic field, one is B and another one is BH, which are two mutually perpendicular to each other. So if it is the case, in that if you keep any needle, it will start to deflect because of both the magnetic field. So when it is deflecting, it will come to rest position with a certain angle, in which tangent of that angle should be equal to the ratio of those two magnetic field, that is B divided by BH. So we know tan theta is equal to B divided by BH. So from that we can come to know the angle in which it is coming. So on that basis it is working. So if you see the instrument of the tangent galvanometer, here first you are seeing the circular coil. This is called as the circular coil, in which the copper wires are mounted. So here copper wires we are taking. Now here knobs are there which will give the number of turns. Number of turns are nothing but what? Suppose only one copper wire if you mounted in a circular type, means number of coils is equal to 1 we will take. If suppose two copper wire if you wound like this, then the number of turns is equal to 2. Like that we are having many number of turns here. So if you connect between these two knobs, means only 2 turns are working. Actually it contains many number of turns, but if you connect to these two, means only 2 turns are working. And if you connect the middle of the two knobs, means 50 turns will be working. And if we connect the last two knobs, means 500 turns will be working. That meaning is, when we will connect to these two, means in only the two circular coils the current will be flowing. When we will pass the current from the power supply, so in only the 2 turns the current will be flowing. So if you connect to the middle, means in 50 turns of the copper wire the current will be flowing. And if you connect to the last two ends, means in all the 500 turns the current will be flowing. Means as we know, the strength of the magnetic field depends upon the strength of the current. If you pass low current, means low magnetic field will be produced. If you pass high current, means the strength of the magnetic field will be more. So to increase the strength of the magnetic field, we should use more number of turns. Means the strength of the magnetic field will be increased. Now suppose I will connect to the middle, means only 50 turns are working. In 50 turns the current will be flowing. So as soon as the current will flow in the circular coil, means copper wire, means it will produce the magnetic field. So that is called as B. So when it is producing the magnetic field, it will be like this, it will be producing. Now the thing is, already we know the earth acts as a magnet, means already it is having the magnetic field strength which is along the north-south direction. That means when there is no current flowing in the tangent galvanometer, means the needle, this is called as the compass box, this is the circular coil, here the knobs are there, and these are nothing but the leveling screw. From that we will mount this one. So it will be rotating like this. Now when there is no current, means here we not connected, so no current is there in the circular coil, that time this is the magnet, this is the magnet, so it will show the direction of the north and south direction. It will be oriented along the what? North and south direction. This is the compass box and this is the compass needle, we will say this is the compass needle which is showing the north and south direction. But as soon as if you pass the current here, no, what will happen? The whatever the current flowing in the circular coil is there, it is produces the what? Magnetic field. So now two magnetic fields we will get. One is already the earth is having magnetic field, that is along one direction will be there, and due to this circular coil another magnetic field will be produced. So due to these two magnetic field, this whatever the needle is there, it will start to deflect like this, isn't it? So when it will be deflecting, after a certain time it will come to certain position and it will make a what? Angle here. So that is called as a theta angle, and that angle is we will calculate by using tan theta is equal to B divided by BH. So this is what about the tangent galvanometer. So now we are moving to the another thing, that is called as Helmholtz galvanometer. So this is what the Helmholtz galvanometer. So if you see both the pictures of the tangent and Helmholtz galvanometer, so in one frame I will show you both the pictures. This is the tangent galvanometer and this is the Helmholtz galvanometer. So if you see, we will come to know here only one circular coil is there in the tangent galvanometer, but in the Helmholtz galvanometer there are two circular coils are there, isn't it? So if you see the figure, you will come to know. And here also the compass box is there and the compass needle it contains. Here also the compass box is there and the compass needle will be there. But here the compass box is there in the only one circular coil, and here the compass box is mounted between the what? Two circular coils. Okay. So for your examination, for your syllabus, only the Helmholtz galvanometer is there. Means when they will ask, explain about the Helmholtz galvanometer, you should tell the principle, the construction and also the working of the Helmholtz galvanometer. So let's go into the Helmholtz galvanometer. So how it may be working. So while telling the definition of the Helmholtz galvanometer, Helmholtz galvanometer is used to measure the DC current, direct current, isn't it? That is the first point. It is used to measure the direct current, and it is the improved form of the tangent galvanometer because the structure is same. Only the difference is here two circular coils are there and there one circular coil is there. So this is the improved form of the what? Tangent galvanometer. Helmholtz galvanometer is used to measure the DC current, which is the improved form of the tangent galvanometer. That is the first thing. And as I already said, it is also working on the principle of the tangent law only. Tangent law means B by BH is equal to tan theta. You just go to my before video, then you will come to know the tangent law completely. Okay. And now when we will go to the principle, it is working on the tangent law. And the second thing for the construction, so if you see both the circular coil, in this way I will show. So here two circular coils are there. This is the first and this is the second coil. So if you see the size of the two circular coil, both are having the same sizes, isn't it? That's why we will say the Helmholtz galvanometer consists of the two circular coil which is having the same radius. So both are having the same radius, that I will take it as D. That I will take it as A. So A be the radius of both the coils because both are having the same radius. Now here also, as I said, knobs are there in which the turns are there. For one circular coil, these are the turns, knobs, where you will do the connection, and for another, here again 4 knobs are there. Now the thing is, as the 2 coils are there, we should connect internally. So both the coils should be connected in series with each other. These two connect in what? Series. By using this and this knob, we will connect to both the circular coil in a series manner. And the next thing, as this is also contains the what? Leveling screw. So this is the first leveling screw, this is the second one, and this is nothing but the what? The third leveling screw. So which is there on the what? 3 leveling screw. So to make it parallel to the ground, we will use the leveling screw. Now coming to the point, as we are seeing, both the coils are there at a certain distance. There is a distance is there between these 2 coils. Now you should measure the distance between these 2 coils. So there is a trick is there here. The trick is nothing but both are having the same radius, and the 2 circular coils is there with the what? Radius of the any one coil. The distance between the 2 circular coil is equal to the what? The radius of the any one coil. As the radius is A we are taking, so the distance is also nothing but what? A. So we will prove by the what? Theory also this one. And then whatever the compass box is there, it is mounted between the what? 2 circular coil, and the magnetometer is there at the center of the 2 circular coil. At the center it is there, magnetometer. Now after connecting in series, one thing, it can rotate about a vertical axis. So if you see, will be what? Rotating about a vertical axis. So after again coming to the rest position, the compass needle will show the what? North and south direction. It will also show the north and south direction. So this is what the construction of the Helmholtz galvanometer. The first point, the Helmholtz galvanometer consists of the 2 circular coils which are having the same radius. Both are having the what? Same radius. Then next thing is, both the coils should be connected in series. Both the coils should be connected in what? Series, which is mounted on the leveling screw. It will be mounted on the leveling screw, and which can rotate about a what? Vertical axis. The next point, the distance between the 2 coils is equal to the what? The radius of any one coil. That is what the distance. And the deflection magnetometer will be there at the center of the line joining the 2 coils. For this circular coil, the center is here, and for another coil, the center is here. So if you join these 2 centers, the magnetometer should be fixed at this center. The line joining the 2 centers, this magnetometer will be what? Fixed. This is what the last point. And as we know, as I said, the magnetic field depends upon the what? Strength of the current, and also the direction of the magnetic field is also depends upon the what? The direction of the current. As we know, when current is flowing in a what? Anti-clockwise direction, then if it is showing the magnetic field in one direction, if you reverse the direction of the current, the magnetic field direction also reverses. So which is showing that the strength as well as the direction of the magnetic field completely depends upon the what? Strength and direction of the current which is flowing in both the coils. This is what the construction of the Helmholtz galvanometer. And the one thing I should say here, as it is a tangent galvanometer, when current is flowing in the circular coil, it produces the magnetic field in a surrounding area. So in all these surrounding area, the magnetic field will be produced. But the thing is, along a circular axis, I proved also this one, the magnetic field will be maximum at the center of the coil. As this is a coil, the magnetic field will be maximum at the what? Center. We proved also in the before video. Now the same thing will happen in the Helmholtz galvanometer also. Here also, when current is flowing, the strength will be maximum at this center. and due to the another coil the strength will be acting at the maximum at this point, and here it is maximum and here it is maximum. But if you go away from the circular coil, no, the magnetic field goes on decreases and decreases. So if you go in this way or in this way, the magnetic field quantity goes on decreases and decreases, and at one point it completely become what? Zero for this coil. And if you go to the this coil, here also the magnetic field is maximum at the center, but if you go away from the center, no, the magnetic field decreases and it will be zero at one point. Now coming to the between the two circular coil, what will happen? So if you imagine the thing, no, here the magnetic field is maximum, but while moving in this way the magnetic field decreases due to this coil. Due to this coil it decreases, but at the same time due to this coil it will be nearer to the second coil, so the magnetic field goes on what? Increases and increases, isn't it? So due to one coil, if magnetic field goes on decreases, and due to the next another coil the magnetic field goes on increases and increases. In a simple way I will tell. So this is a circular coil, the magnetic field will be maximum at the center. So if you move away from the center of any one particular coil, no, the magnetic field quantity goes on decreases. Or like this also we can tell. So if you move towards the center of the coil, the magnetic field increases, isn't it? So in the same way, when we are moving away from the first coil, the magnetic field decreases. But at the same time we are moving forward to the water. It means we are moving nearer to the second coil, so the magnetic field increases. That's why whatever the magnetic field is created between these two coils will be what? Uniform. Because due to one coil if it is decreases, with the same amount it will increase due to the another coil. So it will what? Uniform magnetic field we will created between these two Helmholtz coils, isn't it? So this is very important, and that is the difference between tangent and Helmholtz galvanometer. First difference is here one coil is there, here two coils are there, and here the compass needle will be diffracted between non-uniform magnetic field. How the see, if this is the tangent galvanometer, if you move away from this one, no, the magnetic field strength goes on decreases, isn't it? So here maximum, and if you go away that is goes on decreases and decreases. That's why it is deflected between non-uniform magnetic field. But as we saw the Helmholtz galvanometer, in between that uniform magnetic field is there. That's why the needle will be deflected between what? Uniform magnetic field. That is what the difference between tangent and Helmholtz galvanometer. So I hope you understood very well, and that one I will give in a what? Clear manner. So just go. First thing, the definition of the Helmholtz galvanometer is, it is a electrical instrument which is used to measure the DC current, which is used to measure the what? Direct current, and it is the improved form of the what? Tangent galvanometer. The difference between tangent and Helmholtz galvanometer is, in tangent only one circular coil will be there, and in Helmholtz two circular coils will be there. And in the tangent galvanometer the magnetic needle will be deflected due to non-uniform magnetic field, but in the circular coil the magnetic needle will be deflected between what? Uniform magnetic field. That is what the two difference. And as I said, the Helmholtz galvanometer is based on the what? Tangent law. Tangent law is nothing but what? B is equal to BH upon tan theta, or you can say tan theta is equal to B divided by BH. Here the magnetic field in the box which is placed between two coils rotate in a what? Uniform magnetic field. That picture we will show like this in the book, isn't it? In the exam also we will show like this. Here one circular coil, and this is the another circular coil. O1 and O2 are the two centers, and C1, C2 are nothing but the circular coil. And radius we had taken A, and for another also it is A. The distance also should be equal to the radius. That why we will show it as the A. This is what the compass needle. It is the compass needle. Now only see this circular coil, first circular coil. So the below graph is showing the variation of the magnetic field. As I say, it is the maximum at the center, and if you go away, no, the magnetic field decreases. That's why I shown this is the maximum peak here, and if you go away, means it goes on decreases and decreases, like that I shown. And here this side also it goes on decreases and decreases. And this is the graph due to the second circular coil. Here it is maximum, and if you go away from any one side, no, it goes on decreases and decreases. Now coming to the point, when I will move like this, the magnetic field strength decreases due to this coil, first coil. And as I am going like this, I will be nearer to the what, second coil. So it goes on increases. See, due to first coil it is decreases, but due to another coil it goes on increases. So uniform magnetic field we will get between these two. Uniform magnetic field will be what, created. Now coming to the construction, I said it consists of two circular coils of the same radius. A will be the radius for those. These two coils are connected in what, series. I said already, mounted on the same and capable of rotating about a vertical axis. It will be rotated like this, okay. And next is the distance between two coils is equal to the radius of either coil. So as I said, the distance will be same, which is equal to the radius. And this instrument is provided with the what, leveling screw. Below leveling screw is there to make level to the what, parallel to the ground. And next point, the deflection magnetometer is at the center of the line joining the centers of the two coils. So when we will join these two, no, so at the center of those two, the magnetic needle will be what, fixed. And last one is the deflection of the magnetometer, that is the direction of the magnetic field at the center. It depends on the what, current direction which is flowing in the coil. So due to this coil produced the magnetic field, but it depends upon the what, the direction of the current which is flowing here. So this is what the construction of the Helmholtz galvanometer. This is over the definition, principle and construction. And in the in the next class, I will tell the working of the Helmholtz galvanometer. So how it will be working, and also the theory of the Helmholtz galvanometer. So we will look at the theory of the Helmholtz galvanometer in the what, next class. Okay. Thank you.